Hello friends, welcome to Science with me. My name is Dr. Erica. I am so excited that you are joining us in our Exploring Mars unit as we celebrate the landing of Perseverance, which is so exciting that we're going to have a new rover. Now today we are going to use programmable paper rovers. I love this project because you can learn a little bit of programming, a little bit about how rovers work. You can go explore some of Mars and take some pretend pictures, and you need nothing more than the printout, which is pretty fabulous. Now, if you don't have our printout, you should definitely come support us at patreon.com/RosieResearch. You can also find these printouts on Teachers Pay Teachers if you look up our store, Rosie Research. And in our Patreon, we actually have two sets. We have the Victoria's Crater, which is a little bit easier. So I would start with programming your way through Victoria's Crater. And then we have an advanced project, which is Olympus Mons, which is really fun because that is the tallest volcano in our entire solar system. And you can program a little rover trip around it. Now, programming our rovers to Mars is not as easy as driving an RC car. And that's because Mars is really far away. So it takes a long time for the signal to go get to Mars. I can't say drive forward and then wait for 20 minutes for it to go forward and then say now drive forward again. We don't do it like that. Because one, that would be really hard. Imagine trying to drive a car where you can see through the windshield and you tell the person driving the car, forward 10 feet, and then you have to wait 20 minutes, forward 10 feet, and you have to wait for 20 minutes, go right, wait 20 minutes. It would take a really long time to maybe even just go to the store and get a glass of milk, right? So that's part of the problem. And the other part of the problem is we're not actually always in contact with our rovers. So Earth and Mars are kind of far away, and to be able to talk to each other, we need to have sort of almost a line of sight. We do have satellites that are going around both of them that help us, so we could talk to a satellite when the satellite is around, and the satellite could wait till it can talk to the rover. But we end up just programming our rovers one time per Martian day, which is about a day on Earth, but not quite. So actually, our rover drivers get these really weird shifted days because they're about 23 hours instead of 24 hours. So you might actually have to go in and program at 11 o'clock at night and then do that for a few weeks and then come in and program at 11 o'clock in the afternoon. So we get one chance to give our rovers directions on what they're going to do. And that one chance needs to be everything from troubleshooting if you need to get through some sands where your wheels are spinning, to taking the pictures you want, to taking the samples you want, to traveling to a new place in a safe manner. Because if we roll our rover on Mars, there is nobody there to flip it back over. So programming our rovers is a really tricky task. And we're going to learn a little bit about that in this project. So the first thing you need to do with a pair of scissors is you're going to cut out your little paper rover. You could use a quarter or anything you really want to cut this, to use in place of this little guy. But what I like about this is that it has forward, backwards, right, and left. Because as you program something that's far away, sometimes you might look at a map and you might think right is always this direction, even though it might end up being on the rover's left because maybe the rover is facing backwards. So you really have to think from the perspective of the rover and not the perspective of what you are looking at. All right, so once you've cut that out, we are ready to go. And this one really walks you through what you need to do. I'm gonna grab a pencil so I can write it down. All right, so you have some options on your movements, and I've color-coded it for you where this line is red and it's step 1. So you can imagine my rover starts here, and I want to go up to here. So I want to move forward. Forward is the direction of my rover, so I can color that in. I want to go forward, just like that. And then it wants to know what distance. Well, here's a distance of 1, 2, 3 steps. You'll notice that these are cut into extra small squares. These are actually quarters, so you could go like 1.25 steps if you needed to. All right, so I'm going to go a distance of 3, and these are all in feet right here, so 3 feet. And when I go 3 feet, I always like to do this when I'm programming. I'm now going to move my rover up those 3 feet.
Now the question is, what do I want to do? Well, I want to turn because I can't just go right. I need to turn my rover. My rover doesn't sidestep. So I need to turn my rover, and this is telling me I need to turn my rover towards the right. All right, so I'm gonna turn it towards the right. Which way is the right? Here is the right. I'm gonna turn it right. And it asks me how much do I turn it right, because maybe I wanted to just turn it right part way. And here I'm gonna turn it right at like the angle of a box, which is 90 degrees. So I'm gonna turn it right 90 degrees. And now I'm ready for my next step. My next step is to go over here. You'll notice that if I hadn't turned my rover, it would look like I was going right for that foot. But now I have the forward is going in this direction. So I can go forward, and I'm gonna go forward 4 of these squares, which is the same as 1 foot. So I'm gonna go forward 1 foot. Just like that. And now again, I need to turn, and here, this is the direction I wanna turn. It says it's right. Again, if I wasn't thinking about the perspective of my rover, I might just say go down. My rover doesn't know how to go down. So I'm gonna turn right, and that's my next step. The whole step is just turning right, okay? We don't wanna give our rover too much stuff. We're gonna go right a whole turn, 90 degrees. Well, I guess like a normal right-hand turn. And now I want to go forward, and I wanna go forward how much? Well, I go from 3 to 2, that's 1 foot. And then almost from 2 to 1, but not quite. I go halfway. So I'm gonna go forward 1.5 feet. So I can write that in. I'm gonna go forward 1.5 feet, just like that. And now I need to turn again. This time I wanna turn this way, and my rover is telling me that's turning left, which is gonna be this way, I think. So I can turn left, and that's like a normal sort of corner turn, so that's the 90 degrees, just like that. And then I need to go forward 1 foot, and I'm at my first spot. So I can go forward 1 feet, and I have made it to my first day. All right, and there's multiple days to our Victoria Crater mission. So we have a few days where we have to go around Victoria's crater. This is a fun little fact. It took Opportunity 21 months to get to Victoria's crater, which is a really long time. We can't drive very far on each day. So this one has us go here. We gotta then plan our route. So you don't actually get to just follow all of the steps. You could decide how do you plan the route as long as you don't fall into Victoria's crater. You can plan whatever route you want. And then once we get to Victoria's crater, we actually have to start here, and you can plan however you want to get here, but you have to come down the safe corridor into Victoria's crater because we want to take a picture inside Victoria's crater. So one option might be, oh, I might come up like this and go up and around so I get into that safe corridor. You could also maybe go like this and come up and around into the safe corridor. There's a lot of ways. You could even come up and then come over here, and you could come in to your safe corridor like that. You just need to make sure that we enter Victoria's crater in a safe way to keep our rover safe. All right, so you're now planning your trip, but make sure you don't fall in. And here, we're gonna take a picture once we get into Victoria's crater, because we all wanna see what that looks like. That is that mission. And if you have a lot of fun with that, you can go on our Olympus Mons mission, where you get to take more pictures and you actually get to drill into the surface. A lot more planning your own programming skills for that part. And it's a lot longer, which is a lot of fun if you're enjoying that sort of paper programming. And of course, when you do this, you want to have somebody else execute the program, not yourself. And that's because all of the bugs are going to be built into your head. So if you had said, go right 3 feet, you'll just make your rover go right 3 feet. Whereas if somebody else comes in and they say go right, they'll be like, oh, but I'm turning it. How do I turn it 3 feet? What does that mean? And they'll be like, I don't understand, which gives you a chance to say, oh, I meant turn right and then go forward 3 feet. Because with programming, we have to be very specific about how we talk about things. I hope that you guys enjoy this paper programming, super simple programming you can print out on your own printer.
a lot of fun. We'll get your critical thinking skills going. And make sure that if you don't have it, you can always check us out again at patreon.com/rosieresearch, and make sure you subscribe to our YouTube channel so you don't miss any more of our Exploring Mars fun. Thank you so much for joining us, and I hope you have a lot of fun with this project. Bye, friends.